All right, the second part of this lecture, we're going to cover loops. So sometimes you want to run the same code over and over and over again, either a known or an unknown number of times. For example, we've seen how we can use a script to determine if users have entered a nucleotide that is one of the 4 letters that it can be A, C, G, or T. But let's say we want to extend this to be able to enter not just a single nucleotide, but a whole DNA sequence. So if the user enters the sequence, we want to make sure that all of the values are correct. So, let's start with a string, for example. And, we can see that this string contains a letter that is not one of the valid nucleotides. So this X is not an A, C, G, or T. But how do we determine that? So with our string methods, one of the things we could do is, for example, count. And we can count, okay, the number of X's is not equal to 0. So we expect all of the non-A, C, G's, and T's would be 0. But, we don't know ahead of time, what mistake might be made. So a Y might be included. And so we don't really want to have to, test for every single thing, every single possible letter. So one way we could do that, one way we could solve this with using our available methods is we can count how many good nucleotides there are. So it can only be A, C, G, or T, let's say. And so there's 11, and we can compare this to the length of the nucleotide. So we get a false statement because there are 12 nucleotides in this string, and if we count them and add them all together, there's only 11 of the good ones. So that would be one way we could actually accomplish this just using the stuff that we already know. But hopefully you might notice that this is, if you saw this in someone's code, it'd be kind of confusing what exactly they're trying to accomplish, and you end up having to write a whole bunch of different things. So this is where loops become very useful. So what a loop does is it loops through all of the different elements of a container, of a container, and stores them in a variable of our choosing. So for is the keyword that lets Python know that we're trying to do a loop. DNA is the name of the container. So strings are containers, lists are containers. So you have to feed it like some sort of container object. But that's the name of the object that you want to loop through. And then you have to give it a name. So every time it goes through, we can do something to that in order to figure it out. So for letter in DNA, and now we do this whole indented block business again. So we can have one line, we can have as many lines as we want. All the things we want this loop to do has to be indented by a tab. So let's say we just wanted to do one thing, and all we wanted to do was print it. And so now if we print it, each one of those letters is printed one at a time, A, C, G, C, G, 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 et cetera, et cetera. So if we wanted to do error coding, or error checking, we could do something like this. So for letter in DNA, if letter dot upper not in ACGT, and now we have to do one more tab, so we have to do 2 tabs because we're now also doing an if statement, which also requires tabulation in order for it to know what exactly we want to run. Bad nucleotide. And bad nucleotide, and we'll also add this. So we'll use the concatenation ability of strings. So the addition of 2 strings is the concatenation. So we'll print out this information, bad nucleotide, and then we'll even print out the letter that is bad. And so now when we go through this, most of the time nothing happens because this conditional is false. So letter.upper is not an A, C, G, or T, so that's only true if it's not A, C, G, or T. So the only time this happened is when we reach the X letter, and now it runs this now it enters this if block of code, and then it actually executes this right here. You can also do this on list. So we have a object. What kind of object is this? This is a string object. We can see that because there's these single quotes is how we know. We can also use type to verify that. But we can create a list object pretty easily out of this by using the split method of the string class. And this splits, when we don't provide it an argument, this splits on white space. So all of the spaces are used to split up this string into a list of different words. So what we've done is we've created words out of this phrase, and so we have a list of 6 different strings. So if we wanted to loop through this, so now we have our 4 words is the name of our container. So in this case, it's a list. And the way lists work is that every single element is identified and then stored in this word. So if we wanted to print word, we can do something like this. We could also do upper, etc., etc. So we have all sorts of possibilities that we can do. You can make it even more. We can add more code if we want to, and do an if statement. If t in word dot upper print this word has a t in it. All right, so it prints out this, and then because this has a t in it, it also enters this if loop and then prints this as well. So in both cases, the loop knows how to loop through the elements of the string or a list. And how does this happen? So usually the way this works, usually the way these commands or built-in functions work is that they rely on some sort of magic method of a class. And we'll see why this is a really useful way to do things once we actually start to create our own custom classes, because this allows us to build in things like looping. This allows us to build in things like length. This allows us to build in things like adding into our custom classes, because we can simply just implement some of these custom magic methods. So the way it works for iteration, so the way it works for looping, is Python needs to identify the first element of the array, and then it needs to return the value of the element, and then it needs to know how to find the next element of the array, and then finally keep doing that until it hits the end of the array. So if we look at DNA, so DNA is a string, and if we look at the magic methods that it has, one of them is called iter, and that is an important one. And so if we want to, we can create a iterator by doing this. So one way to do it is by using the magic method. We see we create an iterator object, or we could use the built-in function iter, and then that also creates this iterator object. Once we have this, so let's see, so this is a brand new type of class we haven't seen before. So this is a string iterator class. So this knows how to iterate through a string, and it has, not type, I meant to do dir, and it has a bunch of different magic methods that are associated with it. So an important one for this is next, and if we run next on the iterator, either by using the built-in or by using the magic method. So again, it's always important to remember that these magic methods end up either getting called by an operator or by some sort of built-in function. And each time we run this, we get the next letter of the string. So just as a reminder, the string is ACGCGGG, ACGCGGG, and then XCCGT, XCCGT. So we just ran through this one at a time until we reached the end. And then once we reach the end, we receive this brand new error that we haven't seen before, this exception called stop iteration. And then that's how it knows how to quit. So we've seen now how to loop through containers, how to loop through every single element of a container. Let's say we wanted to create a loop that ran for a certain number of times. So how do we run a loop that runs 10 different times? So one way we could do this is we could create a list that is 10 elements long. And so just a reminder, you can use multiplication in order to do that. So we can take a list that's 0, so a single element. And if we wanted to, we could do something like this. So you can see we ran this 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is not the ideal way to do things, but you should always, it's always, I think, fun to test your knowledge of Python to try to do things in different ways. But what you really want to do is use this range built-in function. And the way this works is it basically allows you to define how many times you want to run something, and each time you do it, it also increments the value by 1. So it's almost like you do something like this. So range 5 and this are almost equivalent. They're not exactly the same, so you'll notice that what is returned is not a list, it's a different class, but you can actually convert this to a list, for example, if you wanted to. So here we see we can also specify the start and stop. And we can go from 5 to 9, for example. And the same thing would happen is if we tried to create a list out of it. We can create 1 to 100 if we wanted to. We can do it by 2s. We can do it by 5s. Et cetera, et cetera. So we have a lot of control over what actually gets created by range, and this should remind you of kind of how the slicing operator works. You have the start, you have the stop, and then you have the increment that you can control. So if you want to run a loop a defined number of times, range is a very useful function for you to know how to do that. Finally, you can also use a while loop in order to do loops, and the way the while loop works is So what you have a conditional, and while this conditional is true, it continues to do whatever you put in the indented code block. So here we've created something that will run infinitely in perpetuity. So this will keep running and running and running and running because this true statement will always be true. So what you're going to see is this printout run a ton of times until I hit Control-C in order to kill it. So how is this loop useful? So you want to do something like this. So while x, so let's set, so x equals to 0, while x is less than 10, print x, and also do this. Okay, so now it only runs 10 times, and it runs while x is equal to 0 up to 9. So why did that work? So x equals 0, the first thing it evaluates is x less than 10. Yes, it is, so it runs this block. It prints it, and then it updates the value of x by 1. So it increases the value of x by 1. Now it looks at this conditional again. Is 1 less than 10? It's not, so this is still, if 1's less than 10, it is, so it enters the code block again. And it does that over and over and over again until x eventually equals 10. Once x is equal to 10, this conditional is false, and so finally this while loop breaks and it stops. You can also use a keyword, which is sometimes useful. So you could do something while true. And we're going to print x again. And we're going to do x plus equals 1 again. So if we do this, we're going to just get it into an infinite loop where it just keeps increasing x by 1 and then prints it out over and over and over again. So let's set x back equal to 0. But let's say we did something like this. Now we can say if x is greater than 20, then do something. And the thing that we're going to do is use this brand new keyword break. And so break is an important keyword to know because this allows you to exit a loop. So this is kind of like an alternative way. It's kind of like hitting Control-C. This is an alternative way to break out of a while loop or a for loop by using this keyword. So we run this. It runs, it prints, it increments, it continues to go into this conditional over and over and over again. But eventually, once x is greater than 20, then it enters this if statement, and then the break is able to escape the loop. All right, so we have covered the basics of the loops, and we also covered the basics of conditionals. And so we'll have a bunch of exercises to kind of increase your ability to use those.